Hello, friends. It's Uncle Sam again, and so we talked about the second order ODE questions. We we also, talked about three different cases, like the distinct real, the real double roots, and the complex roots. We won't be able to solve questions or identify questions that requires these three cases. We'll be solving three different equations that is related to the three cases, and we'll be starting from question one where we have y prime prime minus 5y prime plus 6y equals 0. We can pick our solution for y to be e raised to power lambda x. So these are the steps to follow actually. And you have y prime, you're going to differentiate this, and you have prime, lambda will come to the front, e lambda x, and y prime prime, second order, that's not clear. Lambda square e lambda x, and you need to put all these values into this equation. So you have lambda square exponential lambda x minus 5 lambda exponential lambda x plus 6 e raised by lambda x equals 0. Exponential lambda x lambda square minus 5 lambda plus 6 equals 0. This one comes 0 or that equals 0. Then you have what? Lambda squared minus 5 lambda plus 6 equals 0. You need to solve for lambda, and you can say lambda squared minus 3 lambda minus 2 lambda plus 6 equals 0. Uh, you have lambda minus 3, then minus 2 lambda minus 3 equals 0. Lambda minus 2 brackets lambda minus 3 equals 0. So we have lambda to be 2 or lambda equals 3. These values or these answers are distinct, that is, they are different from each other and they are real values. That is, they are not imaginary, like maybe 3i, maybe I or negative I. They are real values and they are distinct. That is, they are not the same. Then you use the distinct real case general solution, which is y equals what? C1 e raised to power lambda 1x plus C2 e raised to power lambda 2x. Then y equals C1 e raised to power 2x, which is lambda 1, which is 2, plus C2 e raised to power 3x. Thank you. So that's all for the real. We have another question here too, which is y prime prime minus 4y prime plus 4y equals what? 0. You're still going to say y equals what? E raised to power lambda x. Y prime equals what? Lambda x. And y prime prime equals what? Lambda square e raised to power lambda x. And you need to put that into the equation. Lambda square exponential lambda x minus 4 lambda exponential lambda x plus 4 e raised to power lambda x equals what? 0. Then you can bring this out. You're left with what? Lambda square minus 4 lambda plus 4 equals what? 0. You can easily use a calculator if you have a quadratic, if you have a very smart calculator, or you have, so in front of me, I have the FX991ES Plus, and you can use any advanced calculator to just type in the quadratic equation, and from there you'll be able to get your lambda. but still we can try to, you know, bring out the factor, maybe factorization method. I don't know if I'm right with that, but you have lambda square minus 2 lambda minus 2 lambda plus 4 equals 0. Then lambda brackets lambda minus 2 minus 2 lambda minus 2 equals what? 0. Lambda minus 2 lambda minus 2 equals what? 0. Lambda equals lambda equals 2 or lambda equals 2. In this kind of situation, we have real double roots. That is, we have the same roots as our answer. And so this is case 2. Case 2. Then the equation for case 2 is C1 plus C2x all in brackets multiplied by e raised to power lambda x. Y equals what? C1 plus what? C2 x e raised to power 2x. That is it for the for the real double roots. That's for the case 2. And also, let's assume you're given this kind of formula, this kind of question 3. You're giving y double prime plus 2 single prime plus 5y equals 0. So y equals what? Exponential lambda x. Y prime equals lambda exponential lambda x. Y prime prime equals lambda square exponential lambda x. And you can put all these into the equation. You have lambda square exponential lambda x plus 2 lambda exponential lambda x plus 5 exponential lambda x equals what? 0. Then we can just put in all these, outside equals 0. And you're left with lambda square plus 2 lambda plus 5 equals 0. This time around, I'll be using the calculator straight up. And you're going to get your answer as lambda equals minus 1 plus or minus 2 high. So this part is the real and this 2 is the imaginary. And if you remember the equation for the complex conjugate, because this is the complex conjugate case, and if you want to do this, you remember the equation which says y equals to exponential the real x, then the c1 cos omega x, which is the imaginary side, plus c2 sine imaginary side x, and so your y equals what? Exponential minus x minus 1, 1, this is the one here, then c1 cos the imaginary, the real, this is the real rather, minus 1, and the imaginary is 2 cos 2x plus c2 sine 2x. So let us write this and write exponential minus x c1 cos 2x plus c2 sine 2x. Thank you very much. Please like and subscribe to this channel. It really go a long way. Thank you very much.